Welcome, everybody. Thanks for joining us for this AASHTO Product Evaluation and Audit Solutions webinar. I'm Bill Reel. Today, we're going to have a presentation about the evaluations of epoxy resin-based adhesive bonding agents. And we refer to it as ERB for an acronym for that, and we'll be using ERB to refer to this program as we go through. The webinar, it's intended for state DOT members only. So if you're not a DOT representative, we would appreciate it if you would log off with our apology for any confusion there might be. But this is intended just for state DOT members. The webinar is being recorded. You probably just heard it say recording in progress. It's going to be available afterwards on the AASHTO Product and Evaluation and Audit Solutions YouTube channel. And questions. We're going to use the Q&A function that's in the toolbar, the pop-up toolbar on your screen. You can put your questions in there as we go along, and we'll make sure we answer them at the end of the presentation. But we're going to wait till the end of the presentation to talk about questions. So our agenda for today, we're going to have just a little bit of discussion about what the AASHTO Product Evaluation and Audit Solutions program is. In case there's anybody on the call who's not familiar with the program. It used to be referred to as the NetPep program up until a year or so ago, and now been rebranded as a Product Evaluation Audit Solutions program. We'll talk about the ERB evaluation program, including a review of the products that are included and the testing that's going to be performed. Talk about the ERB technical committee roles and laboratory facility roles. We'll talk about the ERB data mine module. We'll do a review of current state usage of the ERB program. And then, as I said, we'll save the questions till the end. Our speakers today are Justin Morris, who's the technical committee chair for ERB. He's from Louisiana DOT. Brenda Waters is our vice chair for ERB. She's from Pennsylvania DOT. We have Janae Dawkins. She works for AASHTO Product Evaluation Audit Solutions, and she's the liaison to this technical committee. And me, I'm Bill Reel, and I'm a contractor that works for AASHTO Product Evaluation Audit Solutions. So the AASHTO Product Evaluation and Audit Solutions program, as I said, we were formerly known as NetPep up until a year ago. This program is a partnership between the AASHTO member agencies and industry participants. And the point is to combine professional and physical resources of the AASHTO member departments to provide product evaluations. And these are done of materials and products and devices that are used in maintenance, construction of transportation infrastructure, as well as transportation safety. And we report the results for state use. We also conduct facility audits of manufacturing facilities. It includes a review of the manufacturing process, the facilities, and the quality control procedures. And again, those are reported to your states for your use. Goals of the program: to develop and conduct meaningful and unbiased, stressing unbiased, product evaluations and manufacturing facility audits that serve the needs of the member states. If your state does a lot of product testing, or perhaps sends people to various manufacturing facilities to audit them, then this program can save time and expense that you're using to do that yourselves. If your state has limited resources for product testing and can't afford to send people to inspect out-of-state manufacturing facilities, then using this evaluation audit program can improve your quality assurance processes. And there's also benefits for manufacturers. They can benefit by reduced testing for individual states and by hosting fewer audit inspections of their facilities. Concept of the program: technical committee designs the evaluation of the facility audit. Technical committee is made up of representatives from state DOTs as well as industry. The state DOTs get to vote on the balloted work plan, the resulting work plan. Industry does not vote on the work plan. It's to be accepted by the AASHTO member states. The manufacturers then can submit their products to be evaluated or the manufacturing facility to be audited, and the manufacturers pay the cost of having their product evaluated or their facility audited. Product evaluations are conducted by labs that are testing facilities that are contracted to the Product Evaluation and Audit Solutions Program, and the audits are conducted by auditors who are under contract to the Product Evaluation and Audit Solutions Program. So they work for us and you. Test results and audit reports are made available to credentialed state users through our data mine. The Product Evaluation Audit Solutions Program does not say if a product passes or fails. That's up to the member state. We provide test results that you can compare to your specs to determine if the product meets your requirements or not. But the program provides testing results, does not say pass or fail. It doesn't take the place of any quality assurance activities that you're doing. If you're collecting project level samples and testing them in-house to make sure the product that shows up on your project is the right one and is going to do what you need it to do. This will not take the place of that. But what it will do is verify that the product that's being produced is capable of you can use it to verify that it'll provide what you need to meet your specs. It doesn't supersede your state requirements. So you don't have to say, using this program does not mean you have to change your specs or your specification requirements, lower the level of tensile strength or whatever the property may be. You use your state requirements, you keep your state requirements, and you use the testing provided by this program to compare with your spec to verify that it's going to meet your requirements. I think it's 28 product categories now that we have. This is a list of all the product categories, the product types that are either evaluated or the manufacturing facility is audited. Today, we're going to focus on the epoxy and resin-based adhesive bonding systems. And I want to point you to our YouTube channel. There's a whole bunch of videos there that are of great interest. I did kind of a really quick overview of the overall program. There's videos that talk more in depth about the program, the product evaluations and the facility audits. There's videos on how to use data mine. There's presentations on specific product evaluation and facility audit programs. For example, the one we're doing today will be on the YouTube channel. If you have people in your agency who didn't get a chance to see this one, you can point them to that YouTube channel and they can see our discussion today. You can get to the YouTube channel from our homepage. There's a link to our homepage. Hopefully most of you know where to find that at this point. But at any rate, there's a lot of good stuff on the YouTube channel. So with that, I'm going to introduce Justin. And Justin's going to get started to talk about the evaluation. There you go, Justin.
Thank you, Bill. Like you said, my name is Justin Morris. I have 14 years with the Louisiana Department of Transportation and managing the adhesive, cementitious, concrete, and steel labs. I've been a member of AASHTO Technical Committee since around 2017. I previously held the chair of guardrail guider rail and took over as epoxy chair around October of last year, but I think was formally introduced beginning of this year. So my portion of the presentation will be focusing on what epoxies are, how they're typically used, and as well as the roles of the ERB Technical Committee and the testing facility. So first off, we'll discuss how epoxies work. Like I said, they're typical applications and uses, their typical viscosities and temperature ranges of which they're applied. So we'll also do a quick description of the ERB Technical Committee roles. Like I said, we'll go over briefly our work plan and specifications utilized. We will also briefly go over the testing facility roles, sampling, and what these reports will generate for your state to utilize to meet, to see if the products meet your specifications. So we start out here with a poll question. what, kind of get a general idea of what our audience is. So what is your role within your agency? Are you materials, construction, design, or other? We'll let this go for about 15 seconds. Okay, good. Well, that's great. So dealing majority in materials here, hopefully you kind of have a general idea of what epoxies are. If not, I think this will be a good source for you to reference back to. So what is an epoxy? Epoxies are, for this technical committee, they are a wide variety of chemistries, and this technical committee evaluates two component epoxies, which are comprised of an epoxy resin, which is generally denoted as part A, as well as a part B, which is either your catalyst or your hardener. The AASHTO and ASTMs classify them according to the application uses, which are numbered 1 through 4 using Roman numerals. They have their viscosities, which are grades 1 through 3, as well as their applied temperature ranges or their classes, which are labeled A through F. Kind of an overview of epoxies. Like I said, it's an A and a B mixed together. Mixing time is critical for your usage. As you can kind of see, once the A and B intermingle with each other, you transfer from your pot life, and then you start to gel, harden where you reach a semi-solid state, and then when you're finally cured, you're a solid material. So some critical conditions of your epoxies. These epoxies generate heat during the mixing and curing process, so your mixing time is obviously very important. Refer to your manufacturer's recommended mixing instructions whenever you're looking at your mixing times, and they're also mass dependent. So mass and temperature dependent. So the warmer or colder it is, the faster or slower they'll cure respectively. The less or more you have of them, the faster or slower they'll cure. The more, the faster. Surface prep is also key with epoxies. A majority of failures that we've seen of the material is not of the product itself. It's due to a dirty substrate or a dirty hole. So going back to some typical applications and uses for epoxies, they can be used to join existing and new concrete surfaces. They can improve the performance of your joint or a nosing, or in some instances can be used as a patch. They're also used to bond raised traffic markers or delineators to your pavement. They can be utilized for dowel connections to connect two slabs of concrete pavements. They are often used in crack repair, which can be either injection or gravity fed. They're predominantly used in overlays from what we've seen in Louisiana. There's some other types as well, but epoxies are one of the main uses there. And as well as they can be used to seal segments of post-tension and precast concrete members. So getting a little bit more into the definitions of the epoxies in according to AASHTO and ASTM, you have your types 1, which is a non-load bearing application for concrete, hardened to hardened concrete. The type 4 would be a load bearing application of that similar usage, hardened to hardened concrete. Then you have your type 2s, which are non-load bearing applications of fresh concrete to harden. And then your type 5 would be a load bearing instance of that exact same scenario. Oh, also, and type 1 and 4 can also be used to adhere other materials to a concrete. Type 3, as discussed, is for a bonding and skid resistant material to a hardened surface. These can be used on your traffic bearing surfaces to give them improved skid or improved friction or just riding quality. Lastly, we have our type 6 and 7s, which are used for bonding and sealing segmental precast elements. Type 7 is for when post-tensioning is not applied. Here's just a general pictures of how segmental bridges are sealed and glued together. So now we're going to get into the viscosities. What is a viscosity? A viscosity is a fluid's ability to resist motion. So grade 1 would be a low viscosity like water. It'll get into your cracks. We have a grade 2, which would be a medium viscosity, more like a syrup. And then you have a grade 3, which is a non-sagging consistency. I could have probably got a better picture of some stickier peanut butter, but you kind of think you get my idea there. Again, typical temperature ranges that these epoxies are used at during the application temperature is a list here. It's important to note that you need to reference your manufacturer's recommendations to figure out which temperature class you have. We have another poll question here. So everyone get ready on your marks. So does your state currently have a list of pre-qualified or pre-approved epoxies? Yes or no? Okay, good. Majority, yes. So then this technical committee can definitely evaluate your these products under the AASHTO and the ASTM specifications. If no, I'd love for you guys to reach out to me and we can discuss how we can help you get a pre-qualified list if that's something that you're interested in. So next up, what is the ERB, technical committee? What are our roles? Now that we understand the types, grades, and classes a little bit more, what does the ERB actually do? The technical committee is responsible for implementing and maintaining the AASHTO ERB work plan. This is done by meeting quarterly via Zoom or phone to discuss any changes with specifications or any potential hiccups that you've seen. Just really discuss everything related to epoxies in regards to the AASHTO and ASTM specifications. We also convene annually for the AASHTO Product Evaluation Audit Solution National Meeting. During this meeting, the modifications and changes to the work plan are discussed and balloted. The specifications that this ERB technical committee utilizes is again the AASHTO M235 standard spec for epoxy resin adhesives, and as well as ASTM C881. There's another test procedure, ASTM E573, which is the standard practice for internal reflection spectroscopy, which gives you your FTIR. These two specifications, the AASHTO 235 and ASTM C881, have been harmonized thanks to the work of the Committee of Materials and Pavements, Subcommittee 4C. And I know we have some of the members on this webinar today, and we'd like to thank that committee as well as Awilda Merced and Kelly Sanger. Another poll question here, now that we've discussed the specifications. Regarding epoxy resins, which specification does your agency reference? Do you reference the AASHTO M235, the ASTM C881, both, or is there another specification that you reference? Okay, kind of all over the place. I thought I'd see either more AASHTO M235 or both, but I think ASTMs are more easily referenced. That's good. Okay, so this technical committee is comprised of state members, both voting and non-voting. We evaluate product-specific epoxy. Sorry, my phone rang, kind of threw me off. It's comprised of state members, both voting and non-voting, industry representatives, they're industry experts, the contracted testing facility, and the purpose is for this technical committee to guide the AASHTO's mission. The roles of the testing facility are to adhere to the testing protocols established by the work plan, which, as discussed, are the AASHTO 235, ASTM C881, and the ASTM E573, where you have your 13 tests, which are listed in your tables of both of those specifications. So these tests are, AASHTO laboratory index tests. They do not reflect typical site and or field conditions. And this program is not intended and should not be used to qualify products for use in sustained load, which would creep. There's another program that deals with that. It's the ICC ES AC 308. That's a whole nother criteria that is not within the scope of this committee work plan. So how are samples, maintained? How does the whole process kind of work? Well, the manufacturer coordinates with AASHTO to get a sample to the contracted facility. They require at least 256 fluid ounces of the sample, which shall be representative of a production lot and is designed to be off-the-shelf unit that is packaged and marked. You'll get a prepackaged slip from AASHTO. You put it on your product and you send it off to the contracted testing facility. These tests are conducted every 3 years to remain published on Datamine and be current. So with that, I'm going to pass it over to Brenda Waters with Pennsylvania, who's going to discuss some more of the testing and the purposes.
Good morning, everybody. My name is Brenda Waters, and I'm the Vice Chair of the ERB Committee. I'm going to talk to you a little about the testing that goes into testing these materials, whether you test it by ASTM CA81 or AASHTO M235. I'm going to go down the list and we're going to talk about viscosity, consistency, gel time, bond strength, and all the other tests that go into ASTM CA81 or M235. So the first thing I want to talk to you about is viscosity, gel time, and absorption. Why is viscosity important? It's important because it determines how thick a material is and how easy the material flows into cracks or gaps. For example, if you have a lower viscosity, it means that the material will flow readily, as the thicker or more viscous material will take a lot longer to flow. So when you want to test for viscosity, you're either going to be using ASTM D2556 or ASTM D2196. Now, a lot of labs may not do their own testing. You may rely on a third-party lab, but they also have to follow ASTMs and AASHTO, whatever procedure that that is geared to use. So, and some also labs do a modified method. You may look at some of the methods that you may not have either the material or the equipment for. So you may do some type of a modified method, but it still corresponds to 2556 or 2196. For this one here, we're looking at a Brookfield viscometer. And for this, you use various spindles. It depends on how viscous the material is. The ASTM or AASHTO you're using will determine which spindle you use. It provides information in centipoise, but the spec, if you read the spec is actually in poise. So also, when you're testing for viscosity, you're using a single component. You do not want to use a mixed system. One of the reasons why you do not want to use a mixed system, because the product, when they're mixed together, it's going to be an exothermic reaction. So it's going to heat up and it's going to react very quickly. So you want to test according to the manufacturer, what's on the manufacturer's product evaluation. Again, it's not meant for a mixed system because the temperature will increase. And you also want to take the temperature in the beginning of the evaluation and at the end of evaluation to see the change in temperature. And what you want to record when you're looking at viscosity, you want to record it in RPMs, you want to record the torque, and you want to record the apparent viscosity. You want to do all that on a form or a sheet, just in case the manufacturer or somebody needs or questions your results. You want to tell them exactly what you recorded, okay? So the next thing I want to talk to you about is gel time. Why is gel time important? Once the resin and the hardener are mixed, they begin to react and become thicker, making the material impossible to pour. So when you condition the materials that you're going to use, like you need a cup, you need a tongue depressor, these materials have to be conditioned according to the class that you're using the material in. Let's say, for example, you're going to use this product in a class A, and class A is for use below 40 degrees Celsius or 4 degrees Celsius or 40 degrees Fahrenheit. So all your components must be conditioned to that specific temperature the product is to be used. So you want to keep that in mind because you have so many different classes of the material. So you want to mix according to the manufacturer's mixing. It's either going to be a 1-to-1 ratio or a 2-to-1 ratio, but either way, it's going to be 60 grams of the material. You want to transfer it to an 80x unwaxed cup. It's just a little Dixie cup like you would have in your bathroom or something like that. You want to, once you transfer it to an 8-ounce unwaxed cup, you want to probe it every 2 minutes in a center. You just want to poke it a little with a wooden tongue depressor to make sure it gels. And this is to begin maybe about 8 minutes after you begin to mix. So you want to look at the time from the time you mix until the time it gels, and your report time in minutes for mixing to gel time. But I have to remind you, if you're performing this test in your labs, you have to work quickly because the shorter the gel time, the shorter the cure. So you want to be careful that you stay right there when you're performing gel time. Next thing I want to talk to you about is water absorption. Why is that important? Well, moisture tends to change the structure of a polymer, which will make it easier to bend or more flexible. So water absorption, even though it doesn't seem so important, is very, very important. It's going to determine if you're using ASTM D570, and it determines absorption of water when it's immersed in water. The mix ratio that you're going to use for your water absorption is the exact same mix ratio that you're going to use for your gel time, and you're going to form a 2-inch diameter, 1/8 inch thick cured for 14 days at 73 degrees. So if you look at the picture, there are different types and different colors of products that you may have, but they're all going to be made, the discs are going to be made in the same way. And only thing you're doing is when you're pouring in a Dixie cup, I think in this instance, you use a small aluminum pan. And every time you do the test, you're going to do always work in threes. You're going to do 3 samples, condition in the oven for 24 hours at 122 degrees, and then you're going to weigh it. You're going to immerse it in distilled water, and you're going to leave it there for 24 hours. When you remove it, you're going to wipe off the excess, you're going to weigh it, and then you're going to record your result. Tensile strength and elongation. Tensile strength and elongation, what it does is it predicts the performance of the material. That's whether it can withstand large loads without compromising the integrity of the product, and if the material is not cured properly. This is when you're looking at tensile and elongation. Now, the picture you're looking at here is a picture of molds of dog bones. When you test strength and elongation, these samples are what you're going to use in order to test for strength and elongation. You can use a silica mold or you can use a Teflon mold when you're looking at tensile and elongation. And another thing people always use, if you want to go to the next slide, these are just die cuts. So another one you can use is a Resin. It's a die cut. Now, I don't usually make the dog bones, but I'm told that it's very hard or difficult to use the die cut with the epoxies. Okay, so 9 times out of 10, you're either going to use the Teflon mode or the silicone mode. And one of the things you really, really have to look at when you're doing these molds, you want to look for things like bubbles. You want to make sure you want to mix according to manufacturer suggestion and cure for 7 days problems. Can you please just fast forward? So what you want to look for, you want to mix according to manufacturer's suggestions. You want to cure it for 7 days. Curing is very important. If it's not cured for the full 7 days, or if improperly cured, you're going to run into samples that are either too brittle or too bendy. So you want to make sure that some of the problems you're going to run into when you're using the molds for the dog bones, you have to use a mold release. If you don't use the mold release, you're going to have problems with pulling a sample out of the molds. So you want to use a spray release. You may run into edge defects, that they may be a little rough around the edges, for lack of a better word. You may find stress cracks the picture to the right, you may see some stress cracks in that dog bones. You may run into thickness variations. So it's very important when you're using these molds to make sure you inspect the mold. And some of the things you want to look for are inconsistencies. If you have bubbles, air bubbles in the dog bones, that's going to interfere with the tensile strength. If you have inclusions, that's also going to interfere with the tensile strength. If you have any bows, for example, may have more sample in certain parts in the middle of the dog bone, that's also going to interfere with it. So when you're making these molds, you have to make sure you inspect the molds first. And when you get the dog bones out, you want to also inspect those also. Now, what you do is you're going to make 12 dog bones, is what PennDOT does. We make 12 dog bones because, again, things go wrong with the 12 dog bones. You want to pick out your best 6 dog bones that you have. And with those 6 dog bones, one of them are going to be used to set up the equipment. So that's very important. You want to make 12, pick up your best 6, and you want to use the best one or either one of those 6 to set up your equipment. Again, what you're going to look for when you're doing your molds and how long it cures, if it doesn't cure properly, you're going to run into some of them that are bold. That is entirely too flexible. So you don't want to see that. You also going to see some differences in thickness depending on your mold. So here you have both on the end are extremely thick. They might be a little bit too thick to put in your equipment, and the one in the middle is a little bit thinner, which will probably just right. How do we test? How do we test for tensile strength and elongation? So this is your 1.2 K Tenius-Olson, and it's just a front and a back view. It's a universal test equipment, what mostly everyone used to test tensile strength and elongation. And you're looking at compression. Since it's 1.2 K, you're looking for force that's under 1,200 pounds. And depending on the type of material, you use various jaws, which is used for gripping. And you want to adjust the jaw grip according to the pressure that's holding the material. The speed is determined by the speed is determined by different materials, and your computer controls the speed or the rate of pull. You also have an extensometer, which measures the elongation, but the thing with your extensometer is limited in the gauge thickness. So that's one of the reasons why your molds is very important and it has to be cured properly, because if your material is too thick, you're not going to be able to, it's going to be too thick for your extensometer. So this is a picture of the jaws that is used to grip the dog bones. And I don't think you can see it here, and I don't believe these are the jaws used to grip these particular dog bones. But if you look closely, if you're able to see it, inside of the jaws are serrated. You'll find these just grooves in it that helps with the gripping of the jawbone, of the dog bones. And this is just a close-up picture of the extensometer. So if what I was saying earlier, if the material is too thick, if the dog bone is too thick, the extensometer can only hold but a dog bone that is but so thick. So, and other times, if you want to put it in the equipment, you may have to use some type of band or a rubber band or something to make sure you keep that dog bone in place. So this is just a close-up view of what it looks like. And this is actually how it holds the equipment. So the jaws on the bottom is what's going to be pulling. And what you're doing here with the extensometer, you're going to be measuring how long or what that distance is for that dog bone of how much it elongated. So that's what you're going to be measuring with the extensometer. Now I want to talk a little bit about bond strength and compressive strength. Bond strength is how well the product will bond to a substrate. You can either test it according to hardened concrete. You can test it to hardened to freshly mixed concrete. The one that you're looking at today was a test of hardened to fresh concrete. So the hardened concrete is cured for 28 days, and you can cure this for 28 days or even longer. It depends on once you're finished with it. You can sit it on a shelf until you're ready to use it. But after that 28-day of cure time, it sits in the open air for 7 days. It's sandblasted. One of the reasons why it's sandblasted is because you want that epoxy to adhere to the surface of that concrete. So once you sandblast it, you want to place it in water for 24 hours, and then you want to allow it to dry. Now it's at that point where you can sit it on a shelf, use it 1 month from now, 2 months from now, or however long it takes for you to be able to use the hardened part. Now you want of the material of epoxy that's brushed on this sandblasted surface, it's only 0.02 inches of the epoxy that is brushed on the surface, and it's hardened to hardened concrete or hardened to fresh. So if it's hardened to fresh, so you'll have this hardened part already in the cylinder. And then what you'll do is you'll mix up your fresh concrete. Of course, your epoxy is already going to be on the surface, and then you're going to pour your fresh concrete into the cylinder, and you're going to allow that to cure. And if you want to look at this, this is the epoxy line that you can see on the material. Now, usually when they're about to test this for strength, they would put sulfur caps on top. And what the purpose of the sulfur caps is, now, if you have the concrete, it may not be totally leveled. So the sulfur caps is going to put it on a leveled or an even playing field. And this is the compressive strength machine. Why is compressive strength important? It's important because it determines how much crushing force the material can handle, how much the product can take before it yields. So they put spacers. So if you look at the picture from the bottom, what happens is it crushes up. They use spacers depending on the height and the size of the cylinder. So the machine doesn't have to compress as much or move as much. And the spacers are just used to take up space to shorten the test. If you had that much space in between tests, it would take that long for the equipment to move up to get a result. The top of the machine is what's fixed, and the bottom is what lifts up, and the max load is recorded in pound force, and it's used to calculate your bond. That's what's used to calculate your bond strength. And this is just a picture of the computer that you use. You have to put information in, like your diameter of the sample, your height, your weight, the age, as long as how many days you allowed it to cure, the break you're expecting, the ramp as what the bottom plate is coming up to, and then you get your results. Now, to test for infrared is just a fingerprint. It's not in CA81 and it's not in M235, but a lot of people, including PennDOT, uses it as a fingerprint. That's all you want to use for. The fingerprint is, say, for example, a company has the contract for the product for the epoxy, and you take a fingerprint of it. And somewhere down the line, you start having issues with the product. Well, you get the product in again and you retest it. So what you're going to look for is you're looking for in the fingerprint, you're looking for peaks that may be present that wasn't there before. You want to look at the intensity of the peaks. You want to look at peaks, maybe they shifted to the left or to the right. So this acts just as a fingerprint to use to have just for your records. Part A and Part B are evaluated separately, and they're evaluated wet. Then you have a mixed cure that is evaluated just the solid. And this is just a close-up of what you're testing. There's a tiny, tiny little hole in the middle of the metal plate. That's how small of the sample that you're testing. You don't need a whole lot of material. You're just going to shave just a little bit off of the product or the dog bone, you're going to put it into your IR and you're going to obtain a scan. And this is just one of what the scans normally look like. This is your Part A resin. This is your Part B, the hardener. As you can tell, the peaks are all different. And then the next slide, if you want to go to the next slide, this is just a combination of the two slides. That's something you're going to see when you do an IR. Again, the only thing you're looking at it for is to get a fingerprint of what the product looks like, just in case you have to refer to it if you get a product that doesn't seem to pass or doesn't seem to perform properly in the field. And I'm going to turn this back over to, well, I want to talk to you a little about other tests that some DOTs don't do. Third party might do them. ASTM C884 with thermal compatibility, that's used to determine if the epoxy product is subject to losing contact or losing adhesion to the concrete when it's used. Concrete with an epoxy overlay is cured, is subject to temperature changes. So what you want to do, because a lot of states, some of the states are cold weather states, you want to, it cycles through freeze thaw, freeze thaw, freeze thaw, and then heat, heat, heat. So you want to cycle this through 5 cycles at 73.5 degrees and -6 degrees for 24 hours each. So you can imagine, and you have to do this for 5 cycles. So it takes a long, long time to do this test. And what you want to look for at the end of this test, you want to look for cracks that's in the concrete near the bond. You want to look for any delineation or delamination because you'll have that separating from the concrete. Also, heat deflection, ASTM D646, heat deflection to test at what point at deformation occurs in the epoxy. And this is tested in sheets consisting of 1/8 of an inch or greater, and it solely depends on how the material will be used determines if this test is necessary. So you won't need to do this test for all class types. Also ASTM D2566, which is withdrawn. It's a linear shrinkage on a resin only on the resin. As it cures, it contracts. So you want to calculate the difference in the length minus twice the film thickness divided by the length of the mold. And like I said, a lot of DOTs don't do this. They refer to the third-party labs to do this test because of the cost or how time-consuming it is. And also for consistency, to determine consistency of the epoxy resin system, it's in 2 parts, and the test is for grade 3 only for non-sagging. So if you get an epoxy in and it's for a grade 1 or a grade 2, you won't need to determine the consistency of the epoxy. And that's used only where the sealant would be applied in a sloped or a vertical joint application, because as you're applying this application, you don't want it to sag or run or anything else. So I think that the stops are a part of testing, and I'm going to turn it over to talk about what is data mine.
All right. Thank you, Brenda. What is data mine? Now that we've discussed what the committee does and what goes into evaluating these products, I'm going to cover a little bit about how states can actually go about accessing this data. So you'll see here the bullet points. Data mine is the online repository of data and audit reports for all services offered by the program. This database provides the tools for performing queries that will assist you in analyzing and reporting on current and past evaluations. And most importantly, to get the most out of data mine, you must always log into your account. There are different levels of accessing data in data mine, and logging into your account ensures that you'll have access to all data, which may not be available for public viewing. For example, the inability to view the ERB reports unless you're logged in. You'll be able to see the current number of ERB product evaluations in data mine, the number of representing manufacturers, and other information available. It may include mixing instructions, SDS, product data sheets, and other information. All right, poll time. Do you have a data mine account or credentials? And it's not letting me launch this. Great. Okay, well, if in the event you do not have a data mine account, or if you're uncertain on whether or not you do have an account, log in. Well, there's a website address listed below, data.netpep.org/home/index. And for those who do not currently have data mine accounts and would like full access to the data within it, please use the registration link on the main page of the data mine site. And you'll see in this red box, it says, forgot your password, and that'll be a good way for you to start the process in retrieving a data mine account. Right here is an example of how an ERB module will look, just to see the listed products that are currently available and the data associated with it. All right. Once you click on a product that you'd like to review the test data for, you have the function options to navigate, search, zoom in or out, view the data in full screen mode, download the report to your computer, or more. So those functions are right there available pretty much immediately after opening the test data portion of it. Okay, here's an example of a test report. It includes a description of testing performed, which includes a summary of the table of test data that's typically provided. The table shows results for each test replicate. The FTR report, the FTR readings are also shared. And why not? Who wouldn't like a printable report that they can access and save for their own record keeping? Okay. And now I'm passing it over for state use of the ERB evaluations.
Okay, so this is Bill again. Thanks, Janae. So I've done survey work related to the ERB evaluations and the state use of them. And this map shows the states that are using it are requiring that products are evaluated by the ERB evaluation. Those are the states that are in green. You'll see there's 3 of them, Maine, Vermont, and Louisiana. The states that are in yellow are states that will allow the ERB evaluation to be used in lieu of some other testing or documentation, and there's 19 of those. There's 28 states that are the gray ones that are not using the ERB evaluation at all. So, I should say, so this originally was done in 2021, but the recent general survey of state use of all the product categories showed that this hasn't changed in the last 3 years. So this map has been consistent for the last 3 years. So let's take a little deeper look into this. We have 17 states that allow the ERB test results to be submitted by manufacturers to fulfill requirements for independent or certified testing. So they require independent testing, and they will accept the ERB evaluation test results to fulfill that need. 14 of the 22 states that report that the ERB evaluations are not used base their product qualification on manufacturer submitted documentation. So that documentation could be include testing, product data sheets, manufacturer certification that the product meets specifications. We have 7 states that perform in-house testing of ERB products, epoxy, resin-based adhesive bonding system products. So, and certainly those states, if they're specifying based on C881 or M235, they could use the testing that's provided by this program and save the resources that they're expending to do their own testing. So, and one state indicated that ERB products are rarely used. So clearly there's opportunity here for many of you to benefit from using the ERB evaluations. Many of you are taking independent test results, which the ERB evaluation would fulfill that requirement. Let's take a look at how some states that are requiring this evaluation are benefiting from it. So I reached out to Vermont to ask them to give me a little information about how they're benefiting from it. So Vermont implemented a requirement that epoxy resin materials be evaluated by the ERB program in 2021. And then since then, they've realized increased confidence in the quality assurance where they had none before. And they've had decreased inquiries from the field staff and contractors because they're now listing these products and basing their evaluation of them on the ERB evaluation. Maine is one of the other states that requires this evaluation program, and they used a phased implementation to give manufacturers time to get through the program, which that's a good way of implementing really any of our product evaluation programs. Basically, let the manufacturer know that you're going to be requiring it and start requiring it for any new products that aren't on your QPL or APL. And in the meantime, you can grandfather the products that are already on your list and give them an appropriate time to get their product submitted and through the process. It may be 1 year or 2 years. I think in this case, probably 2 years is an appropriate time if you give them 2 years to submit their product and have it evaluated. And at the end of that time, you'll have a robust list of products that have been evaluated through this program. And they further stated that using the ERB evaluation gives them assurance that all testing was performed in the same way, and there's no manufacturer influence and results are truly independent. So I thank both Phil and Dawn for providing that information. So with that, why don't we move on to Justin, and he could talk about how his state is using the program.
Thanks, Bill. Yeah, so Louisiana has a QPL, or actually, I'm sorry, we call it an AML now, but we populate it using the ERB information, and it has made our lives a lot easier. It's made it easier on the contractors and the districts, that are out there actually implementing this work to find which products are pre-approved. We also did a 2-year phased implementation. In 2014, we let all of the manufacturers that were on our current AML know that we were switching over to the ERB, which was NetPep at the time. And we gave them a year, say, hey, at least you have a year to get, registered with NetPep and at least submit. And then at the 2-year, they were turned off. And that seemed to be more than enough time to be fair. These evaluations are not very long, and we have a continuously rolling submission cycle for these manufacturers. So it's not like they can fall back and say, well, we missed the deadline. So for Louisiana, like I said, it saved us the additional time and money because like Brenda said, this testing equipment is very precise and expensive. You have to have qualified technicians. The equipment has to be calibrated. So the testing facility that is contracted through AASHTO can take on a lot of that work. The technical committee, relies heavily on the AASHTO M235 and ASTM 881 minimum requirements to help you establish your AML. So all of that testing that goes into those specifications, there's about 13 of them, as well as including the FTIR. For instance, Louisiana can do 6 of the 13, but we can't do all 13 tests. So therefore, I would need to justify the purchase of more equipment, get more employees, and at least with the 6 we can do, we can verify the ERB contracted facilities, data, and then accept the other 7 tests that we can't perform. And we have a good idea that the quality is there and these guys know what they're doing. So, Louisiana logs on to the AASHTO data mine and we look at the ERB information there to populate our AML. And as if your state, you're already participating in this AASHTO. Well, I have NetPep there. I missed that one. The AASHTO program, you're paying for it as part of your annual subscription, and all of the information is there forever on data mine. So this next slide is a picture of, our qualification, Louisiana's qualification procedure for epoxy resin systems, where we lay out our standard specification reference number. We list our AASHTO 235 and ASTM 881. And we show you right there that AASHTO NetPep at the time, because this hasn't been updated, but it is a requirement to have your product listed on our AML. So some reasons of why to consider, like I said, and like we've been saying throughout this presentation, is that this technical committee conforms to the minimum requirements for the AASHTO 235 and ASTM 881. It creates an even playing field for all of your manufacturers and producers. It can enhance your current acceptance criteria for your epoxy resin systems, as well as reduce your quality assurance efforts that you're currently performing. The AASHTO reports are always on data mine, and they can be used to backlog and update your AML. And lastly, you're already paying for it. So this is a provided service that you can utilize and get a list going of the most used products in your state, and it should reduce a lot of phone calls. So this here's a picture of the ERB committee members. Louisiana is the chair, Pennsylvania is the vice chair, and you can see the other states that participate on the quarterly calls as well as represent themselves in the annual meetings. I'd like to thank all of them for their participation. We also have industry members. We have 4 industry, we have 4 companies that provide their products and participate in this program, provide input. And we also rely heavily on the facility, the testing facility, to tell us, hey, you guys are in line or out of line with what your expectations of this committee are. I'd like to give a special thanks to Kelly Sanger with Illinois, Wilda Merced with Florida, the SGS, which was formerly TEC. They are the AASHTO contracted testing facility, and everyone who participates with the technical committee, which would be our voting and non-voting state participants, the volunteers, whether you're volunteer yourself or you're voluntold, and our industry members for their participation. So ways for you or someone in your department to get involved is you can join the AASHTO membership program via the steering committee, one of the multiple technical committees that Bill showed in his slide earlier. And you can figure out who your AASHTO voting member is, and you can become a voting or a non-voting member. Every time Bill or whomever it may be sends out the wellness checks, you can participate in the data usage surveys. You can become AASHTO champion for your state. That could be through Committee of Materials and Pavements or a technical committee or various other AASHTO programs that are out there. It provides you a way to connect with your other states, which are in your region, to figure out how they're utilizing AASHTO, what's saving them money, what's saving them time, what seems fair, what seems consistent, because your manufacturers are going to be supplying to your region, not only to your state.